Today we'll discuss about the graph database. So in the last session we discussed about the column database, document database, key value database. This is another NoSQL database, that is graph database. So here, as the name suggests, graph database is nothing but the diagrammatical representation. By seeing that only we can understand that what are the entities are there, what are the relationships are there between the entities. So entity is named as node in the graph database. We call it as an entity in the relational model, whereas in the graph model we call it as a node. That means the nodes will have different connections. So we'll see what is meant by graph database. Here, graph database is nothing but popular built to store and navigate the relationships. So these are used to store the data as well as to have the relation between one data to another data. So relationships are the first class citizens in the graph database, and most value of the graph database is derived from this of relationships. So in this graph database, we'll only concentrate on the relationships which are existed between the nodes. So graph database use nodes to store the data entities and edges to store the relationships between the entities. Now I'll show you one diagram of graph database. See, look here. This is one node, right? This is one node. This is one node. So all these are the different nodes. These nodes are called as entities in the relational model. So we call it as entities in the relational model. Whereas this arrow, we call it as a edge. We call it as edge. These edges are used to represent the relation between these two nodes. Sam and A. These two are what? What the relation is there between these two people? That is a friend. So nodes are used to store the information, whereas edges are used to store the relationship between the entities. That means between the nodes. Now here, an edge always has a start node, end node, type and direction. So I'm showing like this. So for example, consider student is one node, lecturer is one node. What is relation between student and lecturer? Teaching is nothing but a relation. Student learns from teachers, or learn, L-E-A-R-N. Okay, student, what he is doing? Student learn from lecturer. So this learn is what? This learn is a relation between student and lecturer. Now an edge can describe parent-child relationships, actions, ownerships, and like that. So based on these relationships only, we are going to design a graph database. So you may ask a question. We have key value database, column-oriented database, row-oriented database, document data types. Why we need this graph database? So what is the main important of this graph database? In this generation, everyone in the network, everyone we are in a network. Okay, so to the network we are connecting. Yes or no? Consider a network of a Airtel company. So different Airtel customers are there. All they are related, right? What is the connection between them? So wherever we are forming a network, we have nodes and relationship with the other nodes. In such cases, we need a graph database to represent that scenario. Now there is no limit to the number and kind of a relationship in the graph database. That means how many number of nodes will be there maximum for a graph? There is no limit. And what kind of relation is there between the two nodes is no limit in the graph database. Now, a graph database is a NoSQL database system based on the topographical network structure. The idea stems from the graph theory mathematics, where graph represents the data sets using nodes, edges, and properties. So already we know this graph theory in the mathematics. So node is nothing but, for example, this is one student, this is one student, this is one student, this is one student. All these students are linked to one another. This is a college అనుకోండి. this is college, this is student, this is lecturer, this is offices, this is administration. So each and everyone have relation with what? Each and everyone have relation with college. Yes or no? So this represents what? This represent a graph. Here A, O, L, S, O, C are the nodes. The link between these two nodes is called as a edge. And properties are nothing but what? What relation they have, that we call it as what? Properties. Descriptive information associated with the nodes. In some cases each node have a properties as well. What property it has, what property it has. So college properties were there: college name, college address, college location. Lecturer, lecturer number, lecturer name, lecturer subject. All these are the different properties of the nodes. Okay, nodes with the descriptive properties form the relationships represented by edges, as we discussed that. Now the difference between graph model and the relational model. In the relational model, daily we are discussing about the relational model, which is a traditional model. In this is a student table, this is the lecturer table. In this we have student number, student name, student marks, student Aadhaar number or phone number. Here lecturer number, lecturer name, lecturer subject, right, and lecturer experience or lecturer phone number. Here how you have relation? This is a structural table, this is a structural table, and this table format and this table format both are same. So you are connecting these two tables in the relational model. But whereas in the graph model it should not be like that. Where in the graph model it should not be like that. For this connection of graph, it may lead to another graph. It may consist of 4 attributes, maybe 3 attributes, maybe no attributes, maybe 4 attributes. Any number of attributes it can have in the graph database. So this is a major difference between graph database as well as in the relational database. Next we'll see. Now in graph database what you call, in the relational database what you call. So in the graph database, we have nodes and edges with the properties. But whereas in the relational model, we have tables with rows and columns. Relationships are represented by edges. Here, created using foreign keys and primary keys. With the help of these two keys, we are creating a relation between two tables. So this is flexible, this is rigid. That means this is a structural one. So this relational data model is a structural data model, so it should follow a structure. But whereas in graph model, this is a non-structural data model, so no need to follow any rules and regulation. As the interest of the user, they can design the different graph databases. So it will be flexible. Next, complex queries, quick and responsive. So in this, designing of the queries is very easy. It requires complex joins. If you want to get the data from two tables, in the graph database, it is easy. In the relational model, it is tough. Now, next, use cases. Systems with high connected relationships is graph database use case. Transactions focused on system with more straightforward relationships in the relational model. That means what? If you have more number of connections with the multiple tables, with multiple nodes, then better go for graph database. That means if your connections are more, go for graph database. If your connections are less, go for the relational database. See, in a graph database, traversing joins or relationships is very fast because relationship between nodes are not calculated at query times but are persisted in the database. How many relations you have doesn't matter. That means from one node to, if you want to travel another node, we are least bothered about how many number of edges are there. Only will concentrate on what the relationships they have, that's it. So graph database have advantages for the use cases such as social networking, recommendation engines, fraud detections. When you need to create a relation between the data and quickly query these relationships. If you want to make a database, as well as if you want to perform any operations on the database, if it is in a network, right, like social media network or any other network, then the graph database is very easy to implement. See, consider here example. Following graph shows an example of social networking graph. Give it the people as the nodes. All these are the nodes, and the relationship is edges. You can find out whose friend of friend is this to the particular piece of piece. So ఇక్కడ ఒకటి అబ్జర్వ్ చేయండి. So Harry is friend of Jack. Jock is friend of Annie. If I want to find the relation between Annie and Harry, I can see that by seeing this graph, I can easily say that Harry is friend of Jock, Jock is friend of Annie. So Annie and Jackie both becoming a friends. That means we can retrieve the relationship fastly compared to RDBMS in the graph database. You can find the easy relationships. Why? Because it concentrates on most of the part only in the relationships. So if you want to find any relationship between any two entities, by seeing this graph only you can easily understand. You can easily tell the relation between two entities. Consider example. Now, if I want to move to bus stand, right? If I want to move to bus stand from SSR Degree College. Now what I do, I'll say a route. Go straight, turn left, go straight, take right, go straight, take right. If I say like this, no, by seeing this diagram, you can easily understand that relation is that straight, left, left, go straight. So if I write like that information, you can easily understand by seeing it graphically. If I orally explain with my mouth, go straight, take left, go right, then take left, it may be not understood by the node. That means the relation between one node to another node can easily understood by seeing the graphs, and the relation between also can be identified easily by seeing the graph only. So that is the major importance of the graph database. Next, how the graph database works. How it works. Graph database works by treating the data and relationships between the data equally. That means the priority will be given for the data. The same priority will be given for the relationships also. Related nodes are physically connected, and physical connection is also treated as a piece of data. Modeling data in this way always allows the querying relationships in the same manner as querying the data itself. Instead of calculating querying connection steps, graph database read the relationships from the storage directly. So if you want to find out a relation between one node to another node, we are no need to write a query. From the storage itself, one connection, we have physical connections. ఒక కనెక్షన్ ఇంకో కనెక్షన్ నుంచి వచ్చేస్తుంది. ఫిజికల్ కనెక్షన్ ఉంది అంటే మనం దానికోసం పర్టికులర్ గా క్వెరీ ఏమి రాయాల్సిన అవసరం లేదు. డైరెక్ట్ గా ఇప్పుడు మనం ఒకరితో లింకప్ లో ఉన్నాం అనుకోండి, మనం వాళ్ళతో లింకప్ లో ఉన్నామా లేదా చెక్ చేయాల్సిన అవసరం లేదు. ఆల్రెడీ ఫిజికల్ కనెక్షన్ ఉంది. సో ఫిజికల్ కనెక్షన్ ఉంది అన్నప్పుడు లింక్ అనేది ఆటోమేటిక్ గా మనం ఐడెంటిఫై చేయొచ్చు. నో నీడ్ ఆఫ్ రైటింగ్ ఆఫ్ క్వెరీ ఫర్ దట్. ఫర్ ఎగ్జాంపుల్, ఒక ల్యాండ్ ఫోన్ తీసుకుందాం, రైట్? ఇక్కడ ఇంకో ల్యాండ్ ఫోన్ ఉంది. ఇఫ్ దీస్ టూ ల్యాండ్ ఫోన్స్ ఆర్ కనెక్టెడ్ త్రూ వైర్, దట్ మీన్స్ దిస్ ఈస్ అ ఫిజికల్ wire is there between two land phones. Now I can by seeing this connection, I can say that these two are in a relation. So to retrieve this relation, whether these two nodes are in the relation or not, no need to write a query for that. By seeing that physical connection only, we can easily say that these two nodes are in a connection. So that is the advantage of graph database. Graph databases are more closely related to other NoSQL modeling techniques in terms of agility, performance, flexibility. Like other NoSQL databases, graph do not have schemas. So in the last session, we discussed about the schema. Schema is nothing but diagram. Okay, graph itself diagram. There is no special schema for the graphs. If it is of document database, if it is of column value database, we have key space. We have discussed about the key space. If it is of document database, we have one diagram. If it is of RDBMS, we have relational schema, like the tables are there, these tables are in relation, like the diagrams will be there. But for the graph database, graph itself a diagram, so there is no need of any other schemas for the graph database. Now next, features of the graph database. Features are nothing but how the graph database will work. So first one is creating open source community. So the most successful software often carries open source foundation that grows originally, cover time with the support of thriving community of users. Community in the sense they are forming a network. If the network is formed, more number of users will be there. The users will be considered as nodes and the relation between them is considered as edges. So wherever the community is there, in such scenario, we are going to implement a graph database. So we have different kinds of databases. The very most important graph database that is developed is Neo4j's community. So this community is going to be improved by using this graph database only. So native graph storage. Native graph storage protects the relation information, the entity that connects the data nodes as the primary data element. So already we discussed previously only. One node is there, another node is there. The connection between these two nodes is called as a edge. So this node contains what? Information. This node contains what? Information. Information is nothing but data. The relation between these two nodes will also be treated as data. How much amount of importance you are giving to this data, the same importance you will give for the relation also in the graph database. So I'm repeating this point every time. Why? Because relationships is necessary, important in the graph database. So to store the data, we require memory. In the same manner, to store the relationship also, we require memory, right? This is important as without native graph storage, the vital information could be damaged, lost, or disconnected in the resulting in the data corruption. Non-native graph storage would also mean an increase in complexity, slower processing time, as a query would have to make multiple hops to translate each hop individually. That means by using this native graph storage, we store the data as well as the relation. If you do not have native graph storage, it is very difficult to perform the operations, that means transformations or any checkings or any related issues which are to the graph related. It may not be easy when if you not have native graph storage. Next, acid compliance. That means it follows the rules of the acid properties: atomicity, consistency, isolation, and durability. These four properties are satisfied by the graph database. Next, HTAP, OLTP, OLAP, hybrid transactional analytical platform and online transaction processing, online analytics processing. So in order to analyze the data, in order to analyze the relation between the nodes, we use the concepts of OLAP and OLTP. So this graph database supports to perform these HTAP, OLTP and OLAP. So by doing this, we can identify the fraud detection and identify the access and cyber security, supply chain and metadata management by doing the OLTP, online transaction processing. Online analytical processing is often used for analytics activities such as data warehouse, business intelligence, and data mining. HTAP allows for a combination of OLTP and OLAP. So OLTP means what? OLTP means for transactions. OLAP means for analytics. So if you are transferring some amount from X account to Y account, what we need? We may have a chance of frauding. So if you want to avoid fraudings and if you want to send the amount correctly, whether your database is right or wrong, each one would be identified by OLTP process. Whatever the processes you have in the data, whatever the data you have data in the database, what amount of data you have, how much amount of data you have, how the data you have, that is what we are analyzing the data of the database, that we call it as a data warehousing and data mining techniques, right? Next, extensive tools and support for all kinds of users. So this graph database allows API, that means application programming interface, and It also have different kinds of tools, and it supports all kind of activities for the business users, administrators and scientists, IT operations, everything. So this graph database is used by everyone in the real life. And last one is when not to use a graph database. Actually, this graph database is not required. When? So this graph database is not supported when the queries don't include specific starting points. Now that means what? If college is there, consider college. So under this college only, we have students, we have lecturers, we have management, we have administration, we have like library. If this college is not there, is these have any relation between them? No, right? By seeing them only, you can easily understand if college is there, then all these are necessary. If the first point is not there, then remaining all are not required. So in this case, first point is compulsory. Then only go for the graph database. If you don't have connections with one another, only small amount of connections are there, then go for RDBMS. If you have large amount of connection, then go for graph database. So that only here I am writing. If you need to run a frequent table scans and searches for the data that fits defined categories, a graph database won't be very helpful. Graph databases are well equipped to traverse the relations when you have a specific starting point or at least a set of points to start with nodes of the same label. That means ఇనిషియేషన్ ఉంటేనే గ్రాఫ్ డేటాబేస్ యూజ్ చేయాలి. ఇనిషియేషన్ అనేది లేదనుకోండి గ్రాఫ్ డేటాబేస్ యూజ్ చేయొద్దు. ఒక పర్టికులర్ రూట్ టు రూట్, ఒక బస్ స్టాప్ నుంచి ఇంకొక లొకేషన్కి వెళ్ళాలి అని మనకు తెలిస్తేనే మనం అక్కడికి వెళ్ళగలుగుతాం. అలా కాకుండా ఎక్కడికి వెళ్ళాలో తెలియకపోతే, ఎక్కడి నుంచి వెళ్ళాలో తెలియకపోతే ఏమైనా మనం ట్రావెల్ చేయగలుగుతామా? చేయలేము. సో ఇన్ సచ్ సిచ్యుయేషన్స్ వీఆర్ నాట్ సపోజ్ టు యూజ్ ద గ్రాఫ్ డేటాబేస్. నెక్స్ట్, వెన్ యూ నీడ్ కీ వాల్యూ స్టోరేజ్. If you want to store the values along with the keys, that means indexes and the respected value also, if you need to retrieve the data from the database, the graph database will not give you the information like that. So very often databases are used to look up the information stored in the key value pair. When you have a known key and need to retrieve the data associated with it, a graph database is not particularly useful. That means what? When we discuss a key value database, we have keys as well as the respected pairs of values are there. If you want keys as well as the values of that, then the graph database is not good for that. If you want to retrieve the data as well as the index of that and the value of that, you go with the key value database. So this graph database, what it have only nodes, only relationships. The value of the nodes will not be there with the graph database. So in such case, you are not supposed to use the graph database. And next, when you need to store large chunks of information. If you want large number of information, then the graph database will not give you the information. Just simply it has nodes and relations. More about the data. The node will contain what? Information. That information is not available in the graph database. That means if you want large number of information, large volume of information which is available in the graph database, it is not gives you right information. That means if you have large amount of data, that is not suitable for the graph database. Only small amount of information can be stored in the nodes of the graph database, right? Next, these are the different use cases of the graph database. So fraud detection. So already we discussed, if you want OLAP, OLTP supports this fraud detection. Recommendation engines. Next, master data management, GDPR and regulation compliances, digital asset management, context aware of service, semantic research, network management. All these are the different use cases of the graph database. So wherever you have, see here, wherever you have network, related network topics, there is a graph database. నెట్వర్క్ లాగా ఎక్కడైతే ఫామ్ అవుతుందో అక్కడ గ్రాఫ్ డేటాబేస్ ఖచ్చితంగా ఉంటుంది, రైట్. నెక్స్ట్ విల్ సీ సమ్ ఆఫ్ ద అడ్వాంటేజెస్ అండ్ డిసడ్వాంటేజెస్ ఆఫ్ ద గ్రాఫ్ డేటాబేస్. సో అడ్వాంటేజెస్ ఆఫ్ గ్రాఫ్ database are agility and flexible. As a user what, they can decide the graph and they can design the graph very easily. And representation of relationships between entities is explicit. That means what, this is one node, this is one node, and you draw the relation between these and you specify the relation here. This explicitly you are saying this relation. Query output real time results. The speed depends upon the number of relationships. If you have more number of relations, it may be somewhat complex, but if you have small number of relations, then the graph database will give you the accurate results. But what drawbacks we have? For this draw database, there is no standardized query language. That means what? To retrieve the data from the database in RDBMS, we have SQL, that is structured query language. But to retrieve the data from these nodes, so node contains what? Data. This node contains what? Data. If you want to retrieve the data from these nodes, there is no specific language. That means in order to interact with the graph database, there is no language. So that means what? If you want to interact with other persons, you need one language. Similarly, if you want to interact with a graph database, you need one language. So like that, there is no specific standardized language to perform the operations on the graph database. Graphs are inappropriate for transactional based system. That means in the banking system, where you have performing more number of transactions, the graph database are not suitable. If user base is small, making it hard to find support when running into a problem, right? All these are the drawbacks and advantages of the graph database. And well-known graph database in the market are Jonas graph, Neo4j graph, D graph, Data S-Tax Enterprise graph. So these are the different types of graphs based on the choice of the user, based on the requirements of the user. We have to choose which graph is suitable to the user.